2. Now, if we know two non-consecutive terms of an arithmetic sequence, then we can find the terms that go between them if we know how many terms there are. These numbers are called the arithmetic means. Okay? Yes, but there could be more than one of them. Like we might have 3 numbers in between the two, and we're going to find all 3 of those numbers. Or there might be 5. It is a lot like it. So if we want to find the 5 arithmetic means between negative 6.2, I'm sorry, 6.2 and negative 1.6. Well, let's just kind of draw a picture of what our general idea is that we have. So we have, starting at 6.2, then we have 5 unknown numbers. And then we have negative 1.6. So our first term, this is a 1. This is a what? Okay, 1, 2, 3, 4, 5, 6, 7, yes. Okay, so that's a 7, because there are 5 in between there that we don't know. So to find the numbers that go in those blanks, what do we need to know? The thingy, yes, right, Harrison. We need to know the value of d. Okay, so if we go to our formula for the nth term, the formula was a sub n equals a1 plus n minus 1 times d. Well, we know all the information for that except for d, so that means we can solve for d. So our an, that's the a7, is negative 1.6, plus the a1, 6.2, or sorry, equals, not plus, equals 6.2, plus n minus 1, well, n is 7, so n minus 1 is 6d. So we just need to solve that little equation. Go ahead and solve that. So we find that d is negative 1.3. So now we can come back and just start filling in the values here. So 6 plus negative 1.3, 6.2, would be 4. Now, one of you is wrong. 6.2, yes. 4.9, then 3.6, 2.3, 1, and negative 0.3. So those are the 5 arithmetic means between 6.2 and negative 1.6. Questions so far? Okay, this next part we're just going to look at real quickly. The book goes into how you can actually find an equation from this. We're not going to go that far with it. We're just going to look at the basic idea. If we have an arithmetic series, we know that there is some common difference between the successive terms. So if we have the series 7, 9, 11, 13, 15, we see the common difference is 2. Now, what if you look at a series and you don't have a common difference? Well, first of all, that tells you that it's not arithmetic. Okay? So here we have a series, 12, 20, 30, 42, 56. And if we look at this is called the first differences, because we're taking the original terms and finding the difference of each one. So the difference between 12 and 20 is 8, 20 and 30 is 10, 30 and 42 is 12, and then 42 and 56 is 14. So those are the first differences. Because they're not equal, we know it's not an arithmetic series. But if we take what is called the second differences, so we take those values now and find the difference between each successive number. They all come out to be 2s. So there's the bell. Yes, those would all. So, and for every possible sequence, I don't think so. So here, the fact that the second differences are constant means that this original can be modeled by a quadratic. So it fits the form ax squared plus bx plus c. Okay? So that's all we're going to do with it, is know that if the second differences are the same, you can get a quadratic model. It's not that difficult to actually find that model. It's just a system of equations, but we're just not going to go into that right now. If you're really curious and want to check that out, it's in the book and pretty easy to follow. Okay, an arithmetic series now. Okay, the sequence is just the list of numbers. The series is you're taking all those numbers and adding them together. So an arithmetic series, the indicated sum of an arithmetic sequence. So if we have 2 plus 5 plus 8 plus 11, that's an arithmetic series. Because we have an arithmetic sequence, adding 3 each time. And then adding them together makes that a series. Now here we see what you saw in the homework, this S sub n thing. They didn't really talk about that before that. S sub n is the sum of an arithmetic series. It is n over 2 times the quantity a1 plus an. Yes? Yes, n is the number of numbers that you're adding. So here, this would be S4 for that series. Now, let's look a little bit at where that formula comes from, because I think it'll help the formula make a little more sense. It said that Gauss, when he was in elementary school, was he's a famous mathematician. No. Oh, yes, the Gauss of Gauss-Jordan elimination. That Gauss. Gauss and Jordan are two different people, yes, but the Gauss of Gauss-Jordan. So when he was in elementary school, his teacher wanted to find something to keep him busy for a while. And so she said, I'd like you to add up all the numbers from 1 to 100. Thinking that that would take him a while. And in a very, very short time later, he came up and gave her the correct answer. And this is how he did it. Consider 1 plus 2 plus 3 plus 98 plus 99 plus 100. Okay? Somewhere elementary school. You know what? Looking at that, I'm thinking it would be easier if I do that backwards. What if I do 100 plus 99 plus 98 plus 3 plus 2 plus 1? Wouldn't that be easier that way? Oh, but wait. I noticed something. Look at what we have here. 101 plus 101 plus 101 . How many 101s are there? 100. There are 100 of them. 1, 2, 3 for each 101. Matched up with the... It's okay. They're still 100s, 101s. There are 100 101s there. Here's 1, 2, 3, 4, 5, and on up to 98, 99, 100 of them. So there are 100 101s. Times 101. Add the numbers, 1 to 100. Yeah, that's what I wrote down. Because I decided I wanted to add it the other way. And then I noticed that if I add them up, each pair I get 101. Okay, so what do we do to fix that? 1/2. Okay, yes. So if we take that, we get the sum. And so now we have a similar thing happening here with the S sub n, where we're taking, and each thing is getting accounted for there twice. Notice the A1 plus AN. That's the 1 plus 100 right here. The N is the 100 things we were adding. We were adding 100 things. And the divided by 2, because we added each thing twice. So that's a very important formula for the sum of an arithmetic series. So if we want to find the sum of -3 to 157. Now there's a small problem here. Number 157, which term is that? I know this is the first term, but which term is that? Because I've got to know the value of n. Okay. It's the last one, but my formula requires that I know n. I know how many terms I'm adding together. Okay, the common difference is 5. So if d is 5, how can we find which term number that is? Well, think of the formula for d. The formula to find the nth term, was a sub n equals a1 plus n minus 1 d. So we can use that formula to find the value of n. Okay, so an is 157 equals -3 plus n minus 1 times 5. So if we add the 3 to begin with, we get n minus 1 times 5 equals 160. Divide by 5. 160 divided by 5, should be able to do that in your head. 160 divided by 5, 32. So n minus 1 is 32. That means n is 33. So n is 33. So now we can go to our formula, S sub n, S sub 33 in this case, equals n, 33 over 2, times a1, -3, plus an, 157, to find the sum of all those numbers. So let's see, -3 plus 157 would be 154. Half of 154 is 77. So 77 times 33. Somebody give me what that is. 33, not 31. 2,541 is the sum there. Okay, so we can use that same idea to find the 17th partial sum of this series. Let's skip down to the last example real quick. Notice that this is equivalent to saying, what's our first term? The first term would be 16, because we're starting at n equals 10. 16, how many terms are we going out then? We're going out to from 10 to 32. So how many terms is that actually? Well, if this was 1 and this is 2, that would be 2 terms, right? If we just had a sum from n equals 1 to 2. Now, just hold on. How many terms would we have there? 2 terms. So the number of terms that you're going out is the top minus the bottom plus 1. So how many terms are we doing here? 23 terms. Okay? And if we consider A1 to be 16, then A23 would be the last term. So we can work with the formulas that we've used here to figure out the sum of those. Okay, so the homework for tomorrow, page 605. Have a good day.